So we found that we're always problem solving with our aquaponics system. I'm going to go through and I'm going to show you one of the issues that we were having on a system that I had a bunch of students build. This system was built for a competition that Lake Superior State University holds. It's called the Aquaculture Challenge. I had a bunch of students that decided that they were going to build a system, and we had a bunch of old tanks and a bunch of other equipment lying around that had come from a system. I think it might have been a Nelson and Page system. So we had the fish tanks, we had a bunch of filter tanks, but that was really all we had, and so the students decided to build a really large system off of that. So I'll first start by just showing the system that the students designed and built using those materials. So there's their grow beds. At the end there's a couple of tanks that are used just for catching water. So they're just sump tanks. The water runs back through that line, comes all the way back to a couple of tanks that we've just got media in for the growth of bacteria. And then it overflows into the tank. We've got a bunch of rainbow trout in there right now that students actually raised those last year in our old system. And so they're somewhere in the neighborhood between 9 and 12 inches. They're getting pretty decent size now. And there's the second tank. So the problem that we were having is we weren't draining water fast enough out of the tanks. And the tanks themselves were actually getting ammonia buildup. Whereas if I go and I test the ammonia levels inside of the sump tank, the ammonia levels were fine. So there was just too much waste that was being produced inside the tanks, and I wasn't recycling it fast enough and getting it through the rest of the system. And so we had just a 4-inch pipe with a bunch of holes cut in it, and it just wasn't moving water fast enough. So what I ended up doing is I went and got a 4x6 coupling, just a reducing coupling, and I cut the end of the flange off. About 3/4 of an inch was taken off so that I could put another section of pipe in there. And the outside diameter of that pipe fits nicely right into the drain of our tank. And then I went and bought some thin wall 6-inch pipe, and that thin wall 6-inch pipe is just going to sit right up on top of that. And so with the coupling, we cut a bunch of holes in it just simply using a router. And so now I should get a greater amount of flow through that. So the water's still going to be coming from the bottom of the tank up, and so it's going to be pulling all the waste off the bottom of the tank, and then it's going to run up that standpipe on the inside of the tank. But hopefully we can get a greater volume of water running through the drain system and out to our filtration system to minimize that ammonia issue that we were having. So trying to fix a little bit of a problem based on the design issues that occurred with the initial design that the kids had done. Just trying to get a greater volume of water moving through that overall system. And so then maybe those guys will do a little bit better. They're pretty happy right now. But when that ammonia level got high, they were not very happy. So hopefully this helps you as you are designing your system. Hopefully it's an idea that can assist you in fixing the problems that we've had prior to you having your own problems.